this is the LiAirV from Green Valley International LiDAR with the DJI LiVOX LiDAR complete review. Oh, hey there guys. Well, you really wanted me to do a complete review of that LiVOX LiDAR sensor, so here it is. Today I'm here with the backpack in Indiana Jones fashion, and I'm going to do a complete review of that LiDAR sensor. We're going to go someplace really cool with a nice canyon, nice trees, a good, beautiful place to see some LiDAR data, and fly a mission and show you exactly what the data looks like. Okay, so here we got the M210 drone with that LiAirV installed. We're going to go ahead and just set it up right over here in this clearing and begin recording our static measurements on the GPS from the LiDAR and getting about 5 minutes of static measurements. To continue doing the setup, we have to set up the Gnss base station. Now, the LiAirV from Green Valley comes with its own base station and Gnss GPS antenna. There's a nice little monument marker right here on this manhole. I'm going to place our GPS directly on top of that. And then we're going to set the base station, which is now on. It runs off this Mavic battery. And this will last you on a full battery probably all day. It's very low power. Okay, now that we have the mission planned, the drone's been sitting for about 5 minutes recording static GPS measurements. All the while we have the base station been recording the entire time, and it will continue to record throughout the entire time we're out here. Now it's time to do a calibration flight with the drone. Beautiful takeoff. All right, we're in the air now, and it looks great. It looks a little nose heavy on the takeoff, but other than that, the flight characteristics, they're looking perfect. Let's go ahead and upload that mission plan and start flying the mission. Then, welcome back to the office. Wasn't that a good flight? I had a great time. Did you? I thought it was really good. This bird performed really well, and it carried this lightweight sensor like it was nothing. So the next thing we're going to do is process the data from the LiDAR and the base station to get the point cloud. But before we do that, let's take a second to talk about the tech specs of this LiDAR sensor. So this is the LiAirV package from Green Valley, and inside of it includes the LiVOX mid-40 LiDAR sensor. The LiVOX itself, just the laser sensor, sends out 100,000 laser pulses a second, and this can be configured in 2 different ways. Actually, 3 different ways. It can either do 100,000 pulses per second with 1 return, meaning 1 pulse, 1 measurement, or it can do 200,000 points per second with 2 returns. That means 1 pulse, 2 measurements coming back. And then also it can do 3 returns, but you lose some points there because of the bandwidth limited of the data connectivity of the LiDAR sensor itself. Now, the accuracy of this, it comes out of all of the points come out of this window focused this direction. So this is a little bit contrasting with other LiDAR scanners on the market that will spin around in a full 360 degrees. Whereas this may be good if you're using an autonomous vehicle and you need to see all around the vehicle, it's not necessarily the best thing for a drone. On the drone, you're going to waste a lot of those points shooting straight up into the sky. Whereas the LiVOX, it points all of those points directly out this window towards the ground. Now there is a 40-degree window where it goes 40 degrees in this X direction and Y direction and spins in an interesting cloverleaf pattern coming out. So all those points are going to be hitting straight towards the ground. LiVOX itself quotes that it gets 2 centimeters precision from the sensor itself. Now, this is a little misleading because they measure that at 20 meters, and we're almost never going to be flying at 20 meters. And then the other things that you have to factor in your precision is the fact that inside of this case, to make it a mapping system, you have to have a GPS as well as an inertial measurement unit. So when you combine the accuracy of the GPS along with the accuracy of the inertial measurement unit and the accuracies of the laser sensor itself, you actually get a compounded error that's going to result in something maybe closer to 5 to 10 centimeters. But we're going to find that out when we process the data. Oh, one more important fact. It has a 260 meter range to it. So at 80% reflectivity, it will see something that's 260 meters away. That's pretty darn far. Let's put this LiDAR back onto the drone, plug in the power, and pull the data off the base station. Well, awesome, there we go. That is the data. This looks really good. I am looking at the LiDAR data right now. So right now we're looking at the 80 meter example. The blue is really low and the red is high, so that's the elevation. And this is the canyon right here in the middle. We took off and landed somewhere over here on this side where you see a little bit more density. This is a road that comes along up here, and there's also a road here, and this is all a big valley. And let's go ahead and toggle the 100 meter example. You can see it looks a little bit different on the road. You can see the road marks there. One of the important things to look at with this LiDAR data is seeing just how fuzzy the data is. You can actually pull up something called a cross section, which is going to cut right through the data, and we're just going to look right down the plane of the data, and we're going to be able to see a single line and see just exactly how good the data looks. So let's grab a big area, but then I'm going to shrink this down to really small, 0.1. Okay, so now we can zoom in on that. So right here, this should be a pretty flat area. This is the road up here. And so if we look closely on the road, and let's do one other thing, we're going to colorize the 100 meters. Let's colorize that as red. And then let's grab the 80 meters, turn that on, and we will turn that into, what do you guys say? Let's do yellow. Yeah. And then grab this and we'll turn that point size up quite a bit. Wait, so we just colored what's called the 80 meter yellow. Oh, this is interesting. I did not expect that. I didn't expect that at all. So what I'm seeing here, what do you guys think? It looks like the yellow is thicker than the red, but the red was flown higher than the yellow. Huh. You'd think if you're closer, the accuracy would be higher, and if you're further away, it would be less. What would be something else that could... No, maybe it's something to do with it's like a statistical sampling. So since we flew lower and the lines were spaced closer, so there's more points per square meter. So maybe it's just statistics, like the law of large numbers, but you'd think the distribution would be the same either way. I don't really know. That's a very interesting find. So maybe flying at 100 meters is the way to go. This is a flat, hard surface. This is just the road. So this should tell us because the road is flat. Other things, when you're looking at the thickness of it, maybe it's looking at grass blades, or you're looking at some brush, so it may not be so accurate, but this is a hard, flat surface. So that's about 14, let's round it up, say 15 centimeters. So that 15 centimeters spread is only one part of the accuracy. We also want to make sure that the entire data set is located in the correct location on the Earth. So to do that, we're going to use ground control points using another GPS receiver to make some measurements of the Earth and compare the LiDAR data set to those. So we got our first ground control point, and we're going to use this data to actually check the accuracy from the LiDAR scan. So this is a traditional surveying method, and what we're doing is we're taking static measurements So basically we're taking a measurement from the GPS satellites every second and just keep recording that. In effect, what we're doing with this measurement is we're getting a very accurate single point on the ground, and we're gonna get the accuracy down to about 1 centimeter with this. All right, we're back here in the office. I just finished processing those ground control points using the Opus resources online. Let's see how well they line up with our LiDAR data set. The red point here is what I measured using the external GPS device, and then I used a post-processing technique available online called Opus here in the United States, which basically allows you to do a network adjustment. It takes into account a bunch of other GPSs that are operating around the US and helps you correct your data so that way you can get millimeter precision. So we know that our red dot is very accurate, and we can see it's basically within the fuzz, a little bit on the low side, but just definitely still within the fuzz of our data set. Now for comparison's sake, I went ahead and flew the Inspire and made an orthomosaic and a 3D model using Drone Deploy software. And Drone Deploy is really good at stitching together photos, making three-dimensional models. And so this is the results from that flight. So now we can see here is just a 2-dimensional view, and I'll click onto that 3D view. You can see all the globules, if you will, of the cars and trees. I mean, it's still really good. And something that really amazes me is up here, there's a bunch of trees, but Drone Deploy managed to stitch the trees away into the digital elevation model. So very, very cool stuff with their algorithm, and I cannot wait to see this improve a little bit more. It's already pretty phenomenal. But let's take a look at the model. So this is the 3D model. Now you can see where the challenge would arise if you were trying to grab the ground off of this and see the actual contours of the ground. You know, it's just these trees are just big globules, and that's normal. I mean, you got a camera and that's all you see. So I went ahead and published some of these data sets onto this viewer. And so after you take the data, so this is kind of a 1-to-1 comparison of the LiDAR data to photogrammetry data. But one thing we do is we classify those ground points. So that is now, if you only look at the ground points and get rid of all that vegetation. So, I mean, this is really what you want to see with the LiDAR data. So you want to be able to see underneath those trees in the ground. Okay, so here's a big tree. Yeah, and you can see right here underneath that tree, you're not really getting good penetration. I mean, it's seeing a little bit, but there's a big missing spot. So if we remove that, yeah, we can kind of see that's where the gaps in the data are. I mean, that still looks stunning. Again, comparing this back and forth, back and forth. So you can see it there. You guys see that? And then we do it here. So this is ground classified LiDAR data from the LiVOX LiDAR sensor on the LiAirV Green Valley package. Well everyone, that was the complete LiAirV review. I hope you enjoyed it. We went out and flew the LiDAR, we processed the data, and we got some notable findings, including the accuracy of about 15 centimeters. Now, it's not gonna replace totally the more expensive LiDAR systems like the Regal, and we saw it with that vegetation penetration. And those more expensive sensors will penetrate that foliage and get the ground much more covered. So if you're in the rainforest or somewhere else like this, very dense vegetation, maybe that's probably gonna be the best sensor for you. And also there is the accuracy. So the Regal systems, you're gonna get sub 5 centimeter all the time everywhere. But that being said, it still is a very affordable solution and provides a lot of really great data. So I will be using this, and it will be another tool in my arsenal. But I'm excited to go out and keep flying LiVOX, Regal, LiDAR, photogrammetry, thermal. I got some cool videos coming up with some avalanches and some landslide stuff going on here. So I hope you guys like the video. And as always, like, subscribe, comment below, and I'll see you on the next one.